We're gonna move to another topic. It's kind very similar, very depend also on each other, which is corrcoef, which is gets or abbreviated from correlation coefficient. Let's close the bracket. Okay, so correlation coefficient, as always, why is the reason we choose correlation coefficient? Why we do care about correlation coefficient? Basically, what correlation coefficient do? It does return a matrix of row and columns. So where the column represent random variables and row represent observation. That's why like correlation coefficient is helpful. So it's function used for hypothesis like reject all, fail to reject the null hypothesis. So like it just like it's kind when you are trying to say like data A is like higher in salinity than data B. So maybe this null hypothesis. So how you explain whether to reject or fail to reject, which is don't reject the null hypothesis, you're gonna use a correlation coefficient. And from the name correlation, so it correlates to data with each other, okay? Or even it has another usages, which is like measuring linear association between variable. So it's always helpful in like statistics. It's always helpful like if you are in a company and like trying to sort some data or compare data, it's always like this is a function you would use. Okay, so let's begin. Okay, let's clear now our workspace. It's super helpful, just like right click, clear workspace, and it's gonna be clear. And let's clear also our command window. Yeah, to start just for scratch with the new things. So x equal rand 6 and 1. So random is random number. Y equal rand, same thing, 6 and 1 too. So this will give me a random number between 0 and 1 in form of 6 rows and 1 column. And the values will be like from 0 and 1, like here, it's from 0, 0 minimum, 1 maximum. 6 rows, just 1 column, same as x if I did here in command window. 6 random number, and it's all random number. So just this use like to, if you don't have data and you want to try some function, rand is always like give me random number, random data. So just for practice of like functions, that's why I always use rand. So p equal x y. Okay, make sure I have the blue line, and then 2 multiply by y plus 3. Okay, quick recap, this is space, this matrix, and this is space. Like now x, I'm gonna create like a new column for every space. So now right now I do have 3 columns. So we can see that one column is defined in terms of the other, like x, y, and then 2y plus 3. So like both are now in the same matrix, that's why both are depend on each other. So there is a directly correlation between all the data. So when we do use correlation coefficient, we should expect to see one diagonal shape. And if we are saying right now 1, this means like our data actually correlated to each other. If we didn't see 1, our data is not correlated to each other. And we're gonna see this when we apply this with correlation coefficient. Yes, here we go. And let's try P. And as I said, the data x and y are in the same matrix, so they are dependent on each other. So let's see what we got. Here we go. So I saw right now a diagonal, like bunch of data, but diagonal of 1, 1, 1. This is how usually you can like make sure that the correlation coefficient actually correlates your data. You should see like in a diagonal shape and it's all ones. Okay, let's reinforce this by doing another example. If we said like Q, rand, 10, and 1, something like maybe W equal rand, the same 10 and same 1. Let's this time make like R1. That's very important, by the way, like to make sure that clear your workspace, because like I used X here, right? And I used also X here. So if I didn't clear my workspace, MATLAB gonna think like the X here, it's this values, which is, it's totally different value from -5 and 5. So that's why if you're trying to start a new section, always clear your workspace, clear all the variable, and make sure your variable doesn't overrun or overuse by each other. So I cannot use R and R, that's why I put R1. That's why applying this as we go is the most helpful or effective way to learn. And now I have the Q, I have the W, both have the blue colors, so I'm good. And let's see what we got. Same thing, okay, so I have the data, okay, and I have in diagonal shape, I have 1 and 1. So my data is good, like I have the 1 in diagonal shape, this means give me a positive result.